Hello everyone. So welcome to another video on data sufficiency. And in this video, what we'll be doing is we'll be discussing questions on data sufficiency pertaining to chapters of basic algebra and exponents. Okay. So I have picked up 5 questions on level of 700 to 800 in GMAT. Okay. Interesting questions, and we'll be solving these questions in this video, right? So all the questions that we'll be solving today are simply on the concept of basic algebra and exponent. Okay, so what I'll be doing is I'll be making videos on data sufficiency topic wise, right? So that if you have problems in any particular topic, then you can go through that videos. All right. Okay, let's get going then. Let's start with first question. We'll follow the same drill. I'll show you the question on the screen. You will pause the video first. You'll try it yourself first, because that's the main idea behind making these videos, right? It's your practice which is more important rather than my solving, right? So pause the video, try the question yourself, and then play back in order to understand how to solve a particular question. All right, pause the video and try this question, please. Okay, let's see how we can solve this one. So it says that if 6xy is equal to x square y plus 9y, what is the value of xy? Now, before even moving to statement 1 and statement 2, my first goal of this question would supposedly be to basically solve this equation, right? Because this is basically a fact. Whatever is given to us in the question, that is considered as a fact, right? So let's first solve this part first. So what I'm going to do, I'm going to bring 6xy to the right hand side, and this should give me x square y minus 6xy plus 9y is 0. Then I can take y common, because I would realize that y is the variable which is common in all the three expressions. So when I take y common, this should become x square minus 6x plus 9 is equal to 0. This will become y x minus 3 whole square is equal to 0. X square minus 6x plus 9 is nothing but x minus 3 whole square. Okay. Now what I'm going to do is I'm going to conclude this statement also. So now if y into x minus 3 square is 0, what all possibilities can I have? First possibility is y can be 0. X minus 3 can be anything, can be any number. Second is x minus 3 is 0, which will give us x is equal to 3. And in that case, y can be any number. Third is y will be 0, as well as x minus 3 is 0, which means x will be equal to 3, right? So when we say that a into b is 0, then that basically means either a is 0 or b is 0, or both of them can also be 0, because 0 into 0 is also 0, right? So these are the three conclusions that we can basically draw. Okay. Now let's see what the first statement says. And remember the question, we are basically finding the value of xy. Can we determine the value of xy? That's the actual question, right? Okay. So first statement says that y minus x is equal to 3, which means y is equal to x plus 3. Now let's see from the three statements what all conclusions can be drawn. Now from the first statement we had is y is 0 and x minus 3 can basically be any number. Now if I take this first conclusion into consideration, so if I take y to be 0, in that case x would be equal to -3, which I believe is quite a possibility, right? So y is 0, x is -3. In that case, the fact given to us in the question also satisfies. So fine, when y is 0, x can be -3. So this is from the first conclusion. Second one is x is 3, y can be anything. Now it's given to us that y is equal to x plus 3. So when we take x is equal to 3, in that case y will be equal to 6. Basically combining the second conclusion from the fact and the statement given to us in the first first statement, the information given to us in the first statement. So when x is equal to 3, in that case y will be equal to 6. Now let's move on to the third one then. So third one is y is 0, in that case x is equal to 3. Now that will not coincide with the information given here, because if y is 0, in that case x should have been negative 3. So basically the point is, even if the third one doesn't coincide with the information given to us in statement number 1, now from these two conclusions, the first one is y is 0, x is equal to minus 3. Second is x is equal to 3, y is equal to 6. So from there I can say that xy can be equal to 0 or xy can be equal to 80. Both of them are possible. Both of them are possible. So do I have a conclusive answer? No, I don't have a conclusive answer. Which means now I'll move to statement number 2, and before that we know that it's D, A, B, C, E. So A goes, which means D goes. Let's move on to the second one. It says that x cube is less than 0. Now if x cube is less than 0, then one thing is for sure, that is x will be negative. That is x will be negative. Now let's see which of the three possible solutions that we got from the fact that is, this is 1, this is 2, this is 3, which of them coincide with x is equal to negative. Now the first one says when y is equal to 0, x can be anything. Now this goes with the conclusion from the second statement. Second statement says that x is negative. Now when y is 0, x can be anything. If x minus 3 can be anything, so x can be also anything. So this goes with x being negative. Second one says that x is equal to 3, in that case y can be anything. Now this won't go with x is equal to negative, because in this case we know that x is 3. Now if x is 3, in that case x can't be negative. So this condition won't go with the information given to us in the second statement. Now what's the third one? Third one says y is 0, x is 3. Now this also won't go, because we want x to be negative. The third one, the third conclusion that we have is x is 3. Which means there is only one thing, or there is only one conclusion which goes with the information given to us in the second statement, that is y is 0 and x can be anything. Effectively x is negative. Now x can be any number in negative. It shouldn't matter to us why, because y is 0. So x is any negative number, y is 0. What will be the product of 0 multiplied by a negative number? 0 multiplied by a negative number will simply give you 0. And that's your answer. So hence your answer is option number B, that is statement 2 alone is sufficient to answer the question, but statement 1 alone is not sufficient to answer the question. Okay, the answer to this is simply option number B. Alright, let's move on to the next one. Pause the video and draw this question, please. See, again, understand, just to remind you guys, that our goal is not to find the answer. Our goal again is that from the information given to us in the two statements, can we find the answer? That's our goal. Okay, getting to the exact answer, that's not our goal. All right, let's move to this one. If n is an integer and f of n is equal to f of n minus 1 minus n, we need to find out the value of f of 4. Now first let's understand what this expression means. Fn is equal to f of n minus 1 minus n. For example, let's suppose if I take n to be like, let's suppose some value 5, for example, hypothetically, then that means f of 5 is equal to f of 4 minus 5. If you take n to be 10, then this means f of 10 is equal to f of 9 minus 10. This is basically what the statement means. This expression, this is exactly the meaning of the term. of this expression. Now we need to figure out f of 4. Now if we want to figure out the value of f of 4, there are two things that we can do. One is either we take n is equal to 4. In that case, we will get f of 4 is equal to f of 3 minus 3. Or I can take n minus 1 as 4 also. In that case, n will be equal to 5. So we can also write f of 5. Okay, I made one mistake. This should be minus 4, not 3. I'm sorry. F of 5 will be equal to f of 4 minus 5. Okay. Now what's the first statement? The first statement says that f of 3 is equal to 14. So I can directly get my answer, because as soon as I'll put the value of f of 3 here, I'll simply get the value of f of 4. I'll simply get the value of f of 4, which means statement A alone is definitely sufficient to answer the question, which means B goes out, C goes out, and E goes out. Now we will have only two possibilities. If statement 2 alone is also sufficient, then we'll mark D, and if statement 2 alone is not sufficient, then we'll simply mark A and we'll move ahead. Now statement 2 says f of 6 is negative 1. Statement 2 says f of 6 is negative 1. Now if I take n to be 6, then I can say that f of 6 is equal to f of 5 minus 6. Now if I know the value of f of 6, can I say that using this equation or using this expression that I have just formed, can I calculate value of f of 5? Yes, I can do that. I'll simply put f of 6 as negative 1. So I should get negative 1 is equal to f of 5 minus 6, or in short, f of 5 will be equal to 1. Now once I have the value of f of 5, I already know that f of 5 is nothing but f of 4 minus 5. If I have f of 5, can I calculate f of 4? Yes, I can do that. I'll simply put f of 5 equal to 1. I think I made a mistake. I'm really sorry again. This would be 5, not 1. I'm sorry. But anyways, I hope you guys got the point. So once I calculate the value of f of 5, then I can simply put it in the second equation. I'll get f of 4 from there also. Right? So the point is, both statements individually are sufficient to answer the question. Now what's the value? That's not our concern, right? Our goal is to figure out whether we can find out the value. Our goal is not to calculate what the value is, which means your answer is simply option number D. Okay. All right, let's move on to the next question. Pause the video and try the question, please, and take your time. Okay, if x, y, and z are integers and 2 to the power x into 5 to the power y into z is 0.00064, what is the value of xy? Okay, so first of all, I'm gonna simplify this right hand side for me. I'm not really comfortable with 0.000 and then 64. So this is 0.00064, which I can also rewrite as 64 into 10 to the power minus 5. Now 64 is nothing but 2 to the power 6, right? This will become 2 to the power 6 into 10 is nothing but 2 into 5. So this is 2 into 5 to the power negative 5. So this is 2 to the power 6 into 2 to the power negative 5 into 5 to the power negative 5, which will simply become 2 to the power 1 into 5 to the power negative 5. Now I am much more comfortable. So basically we have 2 to the power x into 5 to the power y into z is equal to 2 to the power 1 into 5 to the power negative 5. Now we need to figure out the value of x into y. And remember that x, y, and z are integers. X, y, and z are, these are integers. Now, what's the first statement? First statement says that z is equal to 20. Statement number 1 says that z is 20. Now, 20 is 4 into 5, which is nothing but 2 square into 5. So, 2 to the power x into 5 to the power y into 2 square into 5 is equal to 2 to the power 1 into 5 to the power negative 5, which means 2 to the power x into 5 to the power y is nothing but 2 to the power 1 into 5 to the power negative 5 divided by 2 square into 5. So I can write 2 to the power x into 5 to the power y as 2 to the power negative 1 into 5 to the power negative 6 into 5 to the power negative 6. Now in the question it's given to us that x and y are integers. Now if x and y are integers, then the only possible solution that we can have is x equal to negative 1 and y equal to negative 6. Because if these two, if the left hand side is equal to right hand side, in that case the powers have to be equal. So in that case we'll get x is equal to negative 1 and y is equal to negative 6. So do we have a specific value of x and y? Yes, we do have. And that is equal to 6. Anyways, it was not required, but still it's equal to 6. So if I talk about D, A, B, C, E, so B goes, C goes, and E goes. Either it's A or it's D. Now let's have a look at statement number 2. So the second statement says that x is equal to negative 1. So we have 2 to the power x into 5 to the power y into z, and that is equal to 2 to the power 1 into 5 to the power negative 5. Now if x is negative 1, then I should get 2 to the power negative 1 into 5 to the power y into z is 2 to the power 1 into 5 to the power negative 5, which means 5 to the power y into z will basically be equal to 2 square into 5 to the power negative 5 into 5 to the power negative 5. Now understand this part is really important. Now one possible solution which will obviously strike you is y will simply be equal to negative 5 and z will simply be equal to 2 square, which is 4. So basically there is only one value of y which we can afford, and that is equal to negative 5. X is already given to us as negative 1, hence we have a conclusive answer which is negative 1 into negative 5, and that is simply equal to 5. But let's say suppose if you think, okay, why can't I take y to be negative 4, which means 5 to the power minus 1 will be still left, and in that case I'll simply take z as 2 square into 5 to the power minus 1. Now 5 to the power minus 1 is nothing but 1 over 5. In that case z should become 2 square by 5. Isn't that a possibility? So no, that is not a possibility. That is not a possibility, because in the question it's given to us that x, y, and z are integers. So let's say you go a step further than that. You say, all right, fine, understood the point. Why can't I take in that case y to be 0? This is also an integer. In that case, the value of z will basically become 2 square into 5 to the power negative 5. Now, would this be an integer? No, because it's 2 square divided by 5 to the power 5, still not an integer. This again goes down. Not a possible solution. And some of you may also think, okay, what about negative values? What about if I take, let's say, or what about positive values? Negative we have already taken. What about positive value? What if I take y to be, let's suppose, positive 1? If you take y to be positive 1, In that case, the value of z will become 2 square divided by 5 to the power 6. Again, not an integer value. Now, since we want integer, so there is only one possible case, that is y has to be negative 5 and z has to be 2 square, which is 4. So again, do we have a conclusive value of x into y? Yes, we do have a conclusive value. So the answer to this question simply becomes option number D. Right? Okay, let's move on to the next one. Pause the video and try this question, please. Alright, let's try this one. Another interesting question. Is P into Q equal to 1? So I think there is no fact given to us in the question. So we'll simply have to jump to these statements. Okay. First statement is P into Q into P is equal to P. Which means I can say that P square Q is equal to P, or I can say that P square Q minus P is equal to 0. Now, in most of the cases, what students usually do is they simply cancel out P's from both the sides and they simply write, okay, Q into P is 1, that's it. That is incorrect because you do not know whether P is 0 or no. Because now when you say that P into Q into P is equal to P, and let's suppose you cancel out this, so basically things don't happen this way in maths. If you want to remove P from both the sides, what we typically do is we will divide both sides by P. Now the problem here is that with the division, the problem is that we do not know whether the value of P is 0 or not. Because if it is 0, then you can't divide. If it is not 0, then yes, definitely you can divide. You can take P common and this becomes PQ minus 1 is equal to 0. Now if this is equal to 0, we will again have three conclusions. Conclusion number 1, P is 0, PQ minus 1 is not equal to 0, which means PQ is not equal to 1. Conclusion number 2, PQ minus 1 is 0, which means PQ is 1, and in that case P is not equal to 0. Third case, P is 0 as well as PQ is equal to 1. These will be the three conditions. So is PQ equal to 1? Is that for sure? No, that's not for sure, because from case number 1, PQ may not be equal to 1, and if P is 0, I'll still get PQP is equal to P. So is statement A or is statement 1 alone sufficient? No, statement 1 alone is not sufficient. So A goes, which means D also goes up. Now let's go through statement number 2. Q PQ is equal to Q. Again the same thing. So this is Q square P minus Q is 0. This is QP minus 1 is 0. Again you will have three conclusions from here, that is Q is 0 and QP minus 1 is not equal to 0. QP minus 1 is 0, which means QP will be equal to 1, and in that case Q is not equal to 0. I'll draw a line also. And conclusion number 3, Q is equal to 0, and at the same point of time QP is also equal to 1. Now again, from these three conclusions that we have drawn, is it necessary for PQ to be 1? No. Because again in case number 1, if Q is equal to 0, in that case we can simply say that QPQ will be equal to Q. So that is not necessary. which means B also goes out. Now the only option that we are left with is basically combining both of them. So if we combine both of them, do we have something in common? That is what we have to look for. So if we combine both of them, then Q is the first one says that the first one from the first conclusion, P is equal to 0 and PQ is not equal to 1. Okay. Now this can basically go with this first statement, because if P is 0 and Q is 0, in that case PQ is definitely not equal to 1. When I'll combine them, I can combine both the ones, that's for sure. P is 0, Q is 0 and PQ is definitely not equal to 1, because in that case product will be 0. Okay. Can I combine 1 with 2? P is 0, PQ is not equal to 1, whereas it says QP is equal to 1. So 1 plus 2 will not be there, because here PQ is not equal to 1 and in this case PQ is equal to 1. So this will not go definitely. And similarly 1 and 3 will also not go, again for the same reason that PQ is not equal to 1 and here PQ is 1. So this will also not go. Okay, what about 2 and 1? PQ is 1. Now again this will not go with 1. 2 will not go with 1 because PQ is 1 and QP is not equal to 1. Okay, what about the second one? The second one says that second and second, if I say PQ is 1, QP is 1, okay, that's going. P is not equal to 0 and Q is not equal to 0. So that is also of course true, because if one of them is true, that either one of them is 0, in that case QP will not be equal to 1. So 2 plus 2 will also go. Can 2 go with 3? So PQ is equal to 1, P not equal to 0. Oops, Q is equal to 0. And 2 plus 3, Q is equal to 0. So in that case, PQ cannot be equal to 1. So 3 will also not go. Okay. Now 3 with 1, P is equal to 0. PQ is equal to 1. Now if P is 0 and if I do 3 plus 1, P is 0, Q is 0, in that case, of course, PQ has to be 0. So 3 plus 1 will not go. In the second one, P is 0, PQ is 1. Now if PQ is 1 and P is 0, won't two things go? No, two things won't go together, because if P is 0, in that case PQ has to be 0, right? So this won't also go. 3 plus 3, P is 0, Q is 0, QP is 1. This will definitely not go, because if one of them is 0, how can the product be 1? So we have 1 plus 1. 1 plus 1 says P is 0. 1 plus 1 says P is 0, Q is 0 and QP is not equal to 1. 2 plus 2 says P not equal to 0, Q not equal to 0 and QP is equal to 1. So what's the question? Question is PQ equal to 1? So PQ can be equal to 1. PQ cannot be equal to 1 also. So again, do we have a conclusive answer from this? No. No, we don't have. Which means C also goes out. Hence the answer is option number E. Hence the answer is option number E. Very interesting question. Alright. Let's move on to the last question of the video. Pause the video and try this question, please. Alright, let's see what we can do about this one. What is the value of 2x plus 2x by 2y? First, let's solve this expression. 2 to the power x plus 2 to the power x divided by 2 to the power y. This is 2 into 2 to the power x divided by 2 to the power y. 2 to the power x plus 1 divided by y. This is 2 to the power x minus y plus 1. Oh, I'm sorry, this is not y, this is 2 to the power y. So 2 to the power x minus y plus 1. Now what's the equation? What is the value of this expression? Basically, I need to figure out this expression. This is what I need to figure out. Statement number 1 says x minus y is equal to 8. So if I know the value of x minus y, then I know this value, this is equal to 8. This will become 2 to the power 8 plus 1, which is simply 2 to the power 9. That's my answer. I'm getting a conclusive answer, which means statement number 1 is giving me a conclusive answer. So that means B goes out, C goes out, E goes out. It's either A or D. Second statement says that x is equal to negative 3y. Now if x is equal to negative 3y, if I plug in the value of x as negative 3y, then this will become 2 to the power negative 3y minus y plus 1. This is 2 to the power negative 4y plus 1. Now do I know the value of y? No, I don't think so I know the value of y. So definitely statement 2 alone will not give me the answer. Hence, your answer is statement number. The answer is option number A, which is statement A alone is sufficient to answer the question. Right, so these are like good level questions, like apart from the fifth one. Obviously you do get easy questions also. So apart from the fifth one, the other questions were, okay, I would say that they were of like good level. So all these questions that I'll be solving in this data sufficiency series, okay, so I'll be making videos for topic wise. So probably for every topic I'll be solving something around like 20-25 questions on data sufficiency, right? So that you have a good enough understanding of how to approach questions based on data sufficiency. All right, okay, then let's keep it here as far as this video is concerned, and please subscribe to the channel, and I hope you are enjoying the videos, you're able to learn a lot. Okay, and if you have any query, if you have any concerns related to GMAT, GRE or SAT exam, you are more than welcome to contact me anytime. All right, guys, thank you so much. Keep watching and keep learning. Thank you so much.